Right.
Yeah, okay. So before I start, let me give a very quick introduction about myself. I'm currently the head of R&D in STT GDC. My previous portfolio within the organization was head of engineering. I built data center for the organization, with the organization for coming to 10 years. So we do have a bit of challenges in our data centers, but I'll come to the problem statement later. But I'll give you a quick introduction of who STT is about first. Next. So the challenge about data center is currently the backbone of all telecommunication. And you can see from here, from finance to even aeroplane, cars, even the Zoom that we're in now, it's all through data centers, through the servers and through the connectivity that's connecting all of us together. But the problem with data center is we are moving into a very highly skilled environment. So we're trying to use technology to support our operations, not so much to remove manpower, but to complement whatever we have. So we're coming to that slides later on. I'll share with you later. Next, please. So this is just to give you an idea of our footprint. We have almost about 100 data centers worldwide. You can imagine the amount of power that we're using. I'm not so sure if we understand the scales, but we are using about close to moving towards 2 gigawatts of energy. That is very, very high, meaning the complexity of the engineering support behind all these data centers is quite challenging. So from that angle, we are, as I said earlier, we're trying to use technology to support us, starting from HQ in Singapore. From there, we will, if the technology is successful and scalable, we will move to other geography, as you can see from where we are, from Europe side all the way to the APAC region. Okay, next. So this is how, just to give you an idea how I do it, my assessment together with ESG later on. These are some of my tick box that I need to look at. The first two blue colors is to tell you these are the things that I always look at. I will identify innovation and development of new technologies, and I'll do technology forecasts, meaning how will your technology support my operation, and how will your technology be part of the frontier that will be supporting us in our future growth. Because without technology, I don't think you will have data center. Without technology, you will not be able to be where we are in the advancement of telecommunication and a few other things like autonomous vehicles, even AI and things like that. Okay, next. So so part of the problem statements which I've shared with ESG and everybody. Now I'm breaking the whole problem statement into three categories. The first category is under design side, which is not under this purview because that falls under the design consultants. They are also harnessing technology to improve the design because data center is quite complex in operation design. So the second one is under construction, which I'm just sharing with you. There may be some similarities in terms of technology, but it's just to give you an idea where I'm trying to use AI or even integrating AI with robotics, AI with sensors, AI with drones to help us in our construction ecosystem. Because if you understand where I'm coming from engineering side, if you're talking about a shopping center, the engineering component is only about 5 to 8%. The rest are architecture and structure. But in the environment that I'm working in now for data center, we are now looking at about 80% of engineering support, meaning there's a lot of redundancy support, there's a lot of complex equipment supporting one another with redundancy. Because I guess you guys have read the newspaper or heard on the news, if data center is down, first, your handphone will be affected. You cannot do internet banking. You cannot even call each other or find out what's going on, what's the latest in the news. So this is the importance of data centers. So it's about 80% engineering, which brings me to the point number 3 about operation support. Now, I'm trying to use technology, which can, as I said, could be AI driven, could be also be part of robotic system, IoT, analytics, and drones, because what I did not share earlier is that, which I'm going to share now, in a data center, the footprint of the building for data center is very big. It can be, from Singapore perspective, it's vertical, about 5 to 6 story high, and we have all the AI servers inside. In overseas, you're looking at probably about 5 to 10, maybe even 15 hectares of land. And the data centers is it's such a big campus that we are facing challenges to do what we call operation support, from what we call troubleshooting, maintenance, and things like that. So we wanted to use technology in this case to help us. In this case, from fault troubleshooting, diagnostics, maybe even fault recovery if possible, because the challenge with human interface is that sometimes we are only given about initial assessment of the fault. Can be we are given about 5-10 minutes to try to understand what's the problem. Given that every downtime that we experience means could be many hours of inconvenience to many people. So this is where we're coming from. So bullet point number 4 is just to share with you that we're trying to use autonomous operation to with minimum human intervention if possible. Because when there's a fault, we want to use technology to help the human in fault troubleshooting if possible. We're also trying to use this technology to scale it, and at the same time to maybe support us in some of the carbon reduction, CO2 reduction. Also help us in our sustainable data center that we are building on. So this is a nutshell of everything. Next slide. I think, yeah. So this one is just to give you a view. Just now, as I said, it can be 5 to 10 hectares of data center. You imagine there's a lot of racks, which is right in the center. Those racks are where the AI servers are, where we have to support those operations. And you can see that within the data centers, we have a lot of engineering equipment, from generators to redundant power support, switchboard, transformer, UPS, if you're familiar with the term. If not, it's okay. You can let me know, or we can do another crash course on data center engineering. All this, even the cooling system, we got chillers, cooling towers, firefighting equipment. All this has to be constantly monitored for operation reliability, to support the racks operation. Now, the challenge with the server is that it's very power hungry. It's very how should I say, it generates a lot of heat. All these are very challenging operating conditions which we need to maintain. So this is where we are in trying to use technology to help us do troubleshooting, narrow down the hotspot or the challenging environment in the shortest possible time, so that we can do regular maintenance instead of doing corrective action. Okay, next. Yeah, so that is a nutshell of what I'm sharing from a technology angle, from SCT's data center angle. I have about 5 minutes for questions, if you have any. If not, I'm also open for further questions later on. Sorry for rushing the presentation. Yeah, back to you guys.
Thank you, TC. Currently, we don't actually have any questions from the floor. If there are any points that you'd like to reinforce before you have to leave, please go ahead.
Yeah, I think to be fair, I am looking at a few things. Technology being an important cornerstone of our eco environment. Basically, whatever we're going to do, we definitely need to do POCs, pilot. I don't think that's the issue. But what I'm concerned about on this is that the challenges is there must be readily supply chain readiness. Supply chain can be equipment-wise, can be skill sets to support us in this operation. Otherwise, we may have the POC, but we don't have the skill sets of supply chain to support. I think that is going to be very challenging. Okay. There was a question about, do you want to focus on cooling efficiency improvement or energy? Now, it's a very good question on this part. I'll be honest with you, you can propose what you have in mind first, because I'm looking at cooling, I'm looking at power, and I'm also looking at safety. So there's a lot of things that I'm looking at, but I suggest you work on what's your strong point, and you can propose something to us first. We can take a look. But before you propose anything to us, then if you got any queries or any questions, you can email to us first, and then we see how to go from there. Because I think, to be fair, we probably need to sync up first so that you don't waste your time in preparing something that whether I see as makes sense or don't make sense. Okay.
All right. All right. Thank you, TC. Thank you for your time and your presentation. It's nearly 5 o'clock, and
It's okay. One last question. I got 1 minute. If not, I'm going to drop off. I'm very sorry about that. Because today is a very crazy day for me. I got meetings from
understood.
8 o'clock all the way until now.
Understood. Um, all right. I think that's where we are at right now. If there are any questions
Good.
from the participants, I will be sure to send them over to your end,
Sure.
and then we can get them resolved.
Yep.
So thank you very much.